In this video, we will solve this numerical problem where a heat pump is driven by a work output of a heat engine. So as shown here, this heat engine extracts 150 kilojoule of heat from a source which is at 1000 Kelvin. This heat engine converts part of that heat into work and remaining heat is rejected to a room which is at 300 Kelvin. Let us say this heat engine rejects QL amount of heat to the room. The heat pump absorbs QL1 amount of heat from the ambient which is maintained at 280 Kelvin. It delivers QH1 amount of heat to the room which is maintained at 300 Kelvin when work input is supplied to it by the heat engine. So the question here is how much total amount of heat supplied to the room together by heat engine and heat pump in kilojoules. So heat engine supplies QL amount of heat to the room. Heat pump supplies QH1 amount of heat to the room. So heat supplied in total by the heat engine and heat pump is equal to QL plus QH1. So to find out total amount of heat supplied to the room, first we will find out how much is QL, and the second thing we will find out how much is QH1. Let us consider the heat engine part first. So for a reversible heat engine, the efficiency of a reversible heat engine is equal to the work output divided by the heat supply. Let's say we supplied QH amount of heat to the heat engine. So work output is equal to QH minus QL divided by the heat supplied QH. So I can also write QW by QH is equal to 1 minus QL by QH. So for a reversible heat engine, the ratio of this heat transfer can be written as the ratio of absolute temperatures. So I can also write 1 minus TL by TH. So TH is the source temperature, that is 1000, and the room temperature I'm considering it is as TL. So for the reversible heat engine, W by QH is equal to 1 minus TL by TH. W is the work output which is unknown, divided by QH is the heat supplied to the heat engine which is 150 kilojoule, 150, that is equal to 1 minus TL is the room temperature, that is 300 Kelvin, divided by TH is the source temperature which is 1000 Kelvin, 1000 Kelvin. Now if we solve this, we will get work output equal to 105 kilojoule. So the work output for this heat engine is 105 kilojoule. We can also write work output is equal to QH minus QL. Work output is 105 kilojoule. Heat supplied to the engine is 150 kilojoule minus QL is unknown. So QL is equal to 45 kilojoule. So this is the heat supplied to the room by the heat engine. So let us calculate how much heat is being supplied by the heat pump to the room. I will say that ambient is maintained at TL1 temperature and room is maintained at TH1 temperature. So for the heat pump, I can write COP of a reversible heat pump is equal to the desired output divided by the work input. So desired output is QH1 divided by the work input given by the heat engine. This can also be written as QH1 divided by what is the work input for the heat pump. It is QH1 minus QL1. QH1 divided by the work input equal to, for reversible heat pump I can write this QH1 as TH1 divided by, and I can also write this QH1 minus QL1 as TH1 minus TL1. So now this equation, we will use this equation to find out QH1. So QH1 divided by work input is equal to TH1 divided by TH1 minus TL1. So the QH1 is the unknown. The work input supplied by the heat engine is 105 kilojoule, that is equal to TH1, the room temperature is 300 Kelvin, divided by TH1, that is 300, minus TL1, the ambient temperature is 280 Kelvin. 280 Kelvin. Now if we solve this, we will get QH1 equals to 1575 kilojoule. So QH1 is the heat supplied by the heat pump to the room. So the heat supplied by the heat engine to the room is 45 kilojoule. The heat supplied by the heat pump to the room is 1575 kilojoule. So the total heat supplied by the heat engine and heat pump is equal to 1620 kilojoule.